Now the idea of completing a square is to get a format that consists of a power 2. Now for A math, you will always be given an expression. For A math, you will always be given an expression. For E math, you're given an equation. Now, so for A math, generally, we will have a number in front of x squared. So in this case, in the case 1 is positive 2. In case 2 is negative 1. Now, for an expression, before you start to complete the square, you have to factorize out the 2 and negative 1 first. For E math, when you're given equation, you can just divide by 2, divide by negative 1. Because E math, you are given equation. But A math, you are given expression. So please do not say divide by 2. You have to factorize out the 2. So you have x squared plus 2x minus 3 over 2. Maybe I shall write this down first. Before you complete the square, you have to ensure that the coefficient of x squared equals to 1. Then you're able to start completing the square. Okay, let's carry on. I'm going to do this slowly. Now the first two items will remain as it is. I'm going to leave some spaces to write something later. Then negative 3 over 2 right at the back. I'm going to do slowly. So what I will do in this blank space is I'm going to add a perfect square minus a perfect square. So inside the bracket will always be half the coefficient of x. Now inside the bracket must only be number. Okay, number. There's no x inside here, okay? So your previous coefficient is positive 2. So half of positive 2 is positive half. I'm going to write down positive 1. So 2 divide 2 is a 1. So the bracket will always be half times the coefficient of x, positive 1. Now your first three items are what you will generate as a perfect square. So my first three items will now become a perfect square. Underneath the square is x, you shall carry forward the x. Underneath the square is plus 1, you shall copy the plus 1. So my yellow color portion now becomes x plus 1 power 2. The green color portion, you can just press your calculator. Minus 1 minus 1.5 is minus 2.5. Lastly, you shall bring a 2 into the square bracket, so there's no more square bracket. Now you have two objectives here. The first is to find the turning point of the curve. Now remember that your curve, right, this is a 2x squared. This is positive x squared graph. We're looking at the U shape. So the turning point is what I need to find the coordinates. So turning point means your x and the y. Your x value shall always come from solving the bracket here. You let x plus 1 equals 0. So x shall be negative 1. There you shall get your x coordinate of the turning point. The y coordinate of the turning point shall always come from the constant that is outside of the perfect square. Now, sometimes you may realize that they may change the order of writing is okay. The constant is what you will see as the y coordinate of the turning point. So it will still be negative 5. I'm going to position these two numbers on the graph itself. I have pre-drawn this for you. Second is to find all the intercepts, which is your y-intercept, x-intercept. To find y-intercept, just let x equals to 0. In the main equation, it's easier. It's easier to sub in x equals 0 here than to sub in x equals 0 at the last stage. So by observation, when x equals 0, y is negative 3. I shall put this on diagram itself. So lastly, to find the x-intercept, you shall press your calculator. So you can press your calculator for this main equation. You shall be able to get the x-intercept easily. And the purpose of doing this is to tell you that my 2x squared plus 4x minus 3 have now transformed into another format. This format is useful to solve something, to prove something. Now, whenever you want to prove that a quadratic is more than or less than equals something, the technique is 100% done by completing the square. Now remember, this is the same thing as whatever we have done before that, okay? So remember from part 1. From part 1, I managed to change this format. After completing the square, I have obtained another format. You're supposed to prove that the whole quadratic is more than equals negative 5. You can also see from the graph point of view. From the graph, the lowest point is negative 5. So the whole curve is more than negative 5. The negative 5, they're referring you to the y value because the left-hand side is an equation called y. Now, we need to know the properties of perfect square. Let's be reminded that perfect squares is always more than equals to 0. If I were to add minus 5 on both sides, let's see what happens. If I add minus 5 on both sides of this inequality, you realize that my expression is the same as the expression in front. The idea, right, one more time, write down the properties of perfect square. From here, you shall make this whole thing appear. So by adding negative 5, you shall make this whole thing appear, and this whole thing is the same as the question, which means that you have proven that the quadratic curve is more than equals to negative 5. Proven. In case you're wondering this, you need to go back to your Sec 2 concept. Say y equals to x squared. Y equals x squared, the graph is like that. You can see that the smallest number for this U shape, the smallest y value is 0. The smallest. So every perfect square must be more than equals to 0. I shall repeat the same procedure for case 2. One more time, factorize out the negative sign. Next, the first two items remain the same. You're going to leave some 3 to 4 finger spaces and bring the minus 4 at the back. So in the middle, you're going to add a perfect square, take away the perfect square. The number that is inside the bracket must always be half the previous coefficient. So half of negative 1 is negative half. So what you do for the next step is to know that the yellow color portion become a perfect square. Underneath the square, you shall copy it forward. So underneath the square is negative half, you shall copy negative half. So the 3 yellow color portion now becomes this portion. And the green color portion, you can just press your calculator. Lastly, bring the negative sign in. So we have successfully completed the square. You must be able to get the turning point. In short, I just write down TP. So do get the coordinates, the x and the y. Now the x will always come from solving the bracket. Let this x minus half equals to 0. So x equals to half. The y value shall always be the constant of the perfect square. So this number will always be beside it. This is your 4, 1 quarter. Position these coordinates on the diagram. So I'm going to put dotted lines. Same thing, you're going to find your y-intercept and x-intercept. Y-intercept happens when x equals to 0. Substitute x equals 0 into the equation, the expression here. So y equals to 4. To find the x-intercept, I shall leave it to you. You shall press your calculator to find the x-intercept. So the purpose of completing a square is to prove questions whereby you have a perfect square less than or more than something. So this left-hand side is the same as part 1. So let's remember what we have done in part 1. So from part 1, I managed to change this format into the perfect square format. The first thing to do is to realize that there is a perfect square. You need to talk about the property of this perfect square. Now we know that this is a negative perfect square. Negative perfect square is always less than equals to 0. I need to make the whole right hand side appear in my current statement. So what I do is I'm going to specially add 4 1/4. I'm going to add 4 1/4 on both sides of my inequality. And when I do that, the format that you wanted has actually appeared. Okay, so whatever you need to appear is not on the left hand side. So I have proven that my quadratic is less than 4 1/4, proven. Now the numbers need not be exactly 4.5. They can change the number to 5 or 10. As long as the number is bigger than 4 1/4, it will do. But generally, for standard questions, they should give you numbers that are the same as the constant of the completed square format.